Good afternoon, everyone. How are we doing? Can somebody unmute herself and tell me himself or herself? How are we doing, guys? Can you hear me?
Yes, we can hear you.
Wonderful. Thank you for responding. I hope you guys are doing well. I know we have been through a lot. I hope everybody is safe, um, and your families are safe. So, guys, I'm just going to give you a little summary of where we are. We will have two online sessions this week. Hopefully, next week we'll go back to campus. And since it's an online session, I should be able to record it and upload the entire class on YouTube. Couple of things. My Zoom account is a free account, so after 30 minutes, it'll kick me out. Most of the time, I'll say, let's get out of this session. I'll come back right away. If I'm kicked out, you'll be kicked out too. If I don't say goodbye properly, rejoin again. Won't happen. It'll give us a warning. It'll say, we'll shut you down in 10 minutes. And I'll give you plenty of time and I'll say things like, let's get out of this session, rejoin right away, and all those things. So we are recording it. You'll have access to the videos. Since it's an online class, I'll be doing most of the talking. In class, I give you some problems, you try, I make eye contacts. I can sense when you don't understand. If you don't understand some of the things I'm doing here, um, can you see my screen, guys? Can you see my screen?
Yes, we can.
Yeah, we can.
Wonderful. Thank you. So I'm going to do everything on the board. And it'll take us about an hour, maybe not 1 hour and 15 minutes. And if you have questions in the last part of the class, I'll be around. So, what's the plan, guys? The plan is this: we're going to work on these problems from 4.6. Okay. Sorry, 6.4. My bad. So, excuse me, I assigned 6.4a, 3 through 9, 6.4b, 3 through 9. I'm going to do 6.4a 3 through 9 and 6.4b 3 through 9. Problems are parallel problems. By the end of our session today, you should be able to do the problems from MATLAB. They're already there. Okay. So let's go ahead and talk about a few basic things. So this section, 6.4 is about rates and ratio. And there isn't a lot to discuss. I'll just define what we mean by rate and ratio. I'll do it from scratch. So ratio, I'm going to start with ratio. Ratio is a form of comparison. Okay. So I can say, or if I say the ratio, the number of boys to the number of girls in a class was 2 to 3. What does that mean? That simply means for every two boys, there were three girls. Or for every three girls, there were two boys. Or out of every five students, two of them were boys and three of them were girls. You can say it in any order, but the numbers have to match. Okay. Every three girls, go with two boys. Every two boys, go with three girls. Out of five, two are boys, three are girls. So that's what we mean by ratio. Ratio is a form of comparison. Now, 2 to 3, that's how we read it. 2:3. It's really numerically, mathematically, it's nothing different from 2/3. Okay. But we don't write it this way. We write it 2 to 3 when we are using the idea of ratio. Once again, guys, since I can make eye contact, if you don't understand what I'm saying, unmute yourself and just ask. I will give you ample warning before I delete a slide, or I'll pause, do all those things when I do the problems. Okay, guys? All right. I'm going to get rid of this little box. What is rate, guys? Rate is I'm going to give you an example instead of defining it. If you know the cost of one candy bar, suppose one candy bar costs $1.50. Okay. what will be the cost of two candy bars? What will be the cost of three candy bars? What will be the cost of four candy bars? That's what we mean by rate. Two candy bars cost 1.5 for the first one, 1.5 for the second one, $3. Okay. Three candy bars cost 1.5 added three times. 1.5 is the cost of one candy bar. Three of them will be 0.5. So that's a very basic concept of rate. The good news is this section is relatively easy. We'll do 6 or 7 problems and you will be teaching them in grade 5. So it's not a bad section. So if you know the cost of one candy bar, you can find the cost of two candy bars, you can find the cost of three candy bars, four, so on and so forth. Or if you know the cost of four pizzas, how do you find the cost of one pizza? Well, let's do that. It's kind of the opposite, okay? Pizza and candy bars, these are just examples, right? Suppose the cost of three identical pizzas, I mean identical, I didn't write it, is $36. Okay? You need to find the cost of one pizza. What would you do? Cost of it's given. Cost of three pizzas is $36. What's the cost of one pizza? Well, to find the cost of one pizza, you're going to take 36 and divide it by 3. So you can go both ways. That that's the basic idea regarding rate. And we defined ratio earlier. Any questions on what we mean by rate, what we mean by ratio, the basic definitions? Just want to make sure I'm recording. Yes, I am. If we don't have any questions, I'm going to go ahead and do 3 through 9. It shouldn't be a problem. We should be able to do them. I copy pasted these problems from your text. They are 6.4a, 6.4b are parallel problems. You should be able to do them. The problems in MATLAB are very, very similar. Maybe the story changes a little bit. Again, if you can read it, the font is too small, you let me know. So this is number 3 from 6.4a. If the ratio of boys to girls in a class is 2 to 3, let's write it down. And you want to be consistent, boys to girls, not girls to boys. You can write it that way, then you have to change the number too. So again, as before, for every 2 boys, there are 3 girls. For every 3 girls, there are 2 boys. Out of 5 students, 2 are boys, 3 are girls, so on and so forth. What is the ratio of boys to all students in class? Well, we just said that means out of 5 students, there are 2 boys. We're going to say boys to students is going to be 2 to 5. That's part A. Why? I don't ask those questions on the exam. Why? The answer to why would be that's how ratio is defined because boys to girl, the ratio of boys to girl is 2 to 3. That means out of 5 students, there are 2 boys and 3 girls. You can just pretty much paraphrase what ratio means, but I won't ask you why, but hopefully you understand. If, part B, if the ratio of boys to girls is m to n, m is a whole number, you can have a fraction of boys, n is a whole number, you can have a fraction of girls. So we're working on part B. If the ratio of b to g is m to n, find the ratio of boys to students. You would probably do something very, very similar. Boys to students is going to be boys is m, and students will be m plus n. That's my part B. All right. Now, let's work on the last one. Just to let you know, ratio, concept of ratio is they go hand in hand. They are not identical. They go hand in hand with fractions. Okay. So 3/5 of the class are girls. Okay. We kind of know how to represent that. 3/5. So let me make a strip that's 5 units long. Okay. Okay. This is the class. Okay. 3/5 are girls. I'm going to make the girls yellow. These boxes represent the girls. And let's make the boys, what should I make? Red? Oh, sorry. Let's make the boys purple. Okay. And we can also write B, sorry, this is for G, my bad. G, G, B, B. Now I have represented that 3/5 of the class are girls. 2/5 are boys. I can infer that, but I don't need it here. What is the ratio of girls to boys? Now look, each yellow little rectangle would be worth 3, then everything here would be worth 3. If each yellow rectangle or each blue rectangle represents 4, whole thing will be 4, 4, 4, 4, 4. So now they're saying what's the ratio of girls to boys? So for every, so by looking at this picture, I can say for every 3 girls, ratio of girls comes first here. And you want to be consistent. 3, 2, 2. For every 3 girls, there are 2 boys. That's my part. So I'm going to pause it just a little bit. Just for the record, it's being recorded. It'll go to YouTube. You'll have access to the whole link. But if you're copying, I'll pause it just a little bit because we wrapped up number 3. Okay, while we are discussing this, about our exam, guys, don't panic. When you come back next week, we're supposed to meet face to face. Hopefully, Milton will not be an issue for us. I'm keeping my fingers crossed. Everything goes well. You come to class. We all discuss with you. Do you want to take the exam? Certainly, we are not having it on October 10th. We are not having the exam on October 10th as scheduled. We're not doing it. We come back on Monday. You discussed. You could say, yeah, let's do a review session today, and we can do it on Wednesday. You could say, no, let's do it next week. We kind of need to recover. That's fine. So I'll give you a little bit of space. I don't know what you guys are going through. I hope it's not too bad, but it could be. So I'm aware of what everybody's going through. I have colleagues who lost power for 15 days. I didn't lose it for that long. I was lucky, but just so that you understand, there won't be an exam right away. We'll discuss, and I want you to relax. Any questions regarding the exam or this problem number 3? Okay, guys, moving on. If you think I'm going too fast, since I cannot make eye contact, you just tell me. Slow down or pause here a little bit, something like that. Okay, let's do number 4. Okay, there are approximately 2 pounds of muscle for 5 pounds of body weight. Okay, so 2 boxes, if 2 boxes represent muscles, out of 5 boxes, 5 boxes will represent your body weight. So let's see how we can. Again, I like to do things visually. If you can do it in your head, be my guest. So I'm going to take 5 boxes to represent the entire body weight of a person. Okay. Muscles, I'm going to label them red. Okay. And if you want, I can write M just to highlight that we're talking about the muscles here. So if you weigh 5 units, whatever the unit may be. Two of those units will be the weight of your muscle. That's what the first line. There are approximately 2 pounds of muscle for every 5 pounds of body weight. That's what it means. And that's why we have a picture that looks like this. Now, we are not talking about somebody who weighs 5 pounds. Even babies weigh more than 5 pounds, right? Newborn babies. So, what I'm going to do, they are saying this whole thing is 90 pounds for a person. This whole person's, the entire weight of the person is 90 pounds. No. They want us to know how much is the weight of the person's muscle. Now, if 5 boxes represent 90 pounds, I would like to know the weight of each box or the worth of each box. And in order to do that, I simply need to divide 90 by 5, and that turns out to be 18, if I'm not mistaken, but I'm going to pause here and check. 50, but that sounds about right. So now I know each box is worth 18 pounds. These two boxes should be worth 18 times 2 or 36 pounds. And I'm going to write 18 times 2 here. So my answer is 36 pounds. I'm going to pause it just a little bit, just a couple of minutes. All right, guys, let's see if we can grab the next problem. Okay, this one is a rate problem. Okay, which is a better buy? 4 grapefruits for 80 cents, for a total of 80 cents, or 12 grapefruits for a total of $2. I'm assuming the grapefruits are identical. So I'm going to say case one, 4 grapefruits for 80 cents. Case two, 12 for $2. How do I know which is better? Remember, guys, when we defined rate, we said if I know the cost of 4 grapefruits, I need to find the cost of one grapefruit. If I know the cost of 12 grapefruits, I need to find the cost of one grapefruit. And then I'm going to decide which is better. I need some room. To make it too small, you let me know. So, okay, this is case two. All right, so here I'm going to say one grapefruit, one grapefruit costs 80 cents divided by 4. And that turns out to be 20 cents. In case one, cost of each grapefruit is 20 cents. In case two, the cost, one grapefruit costs, don't write $2, write 200 cents because you want to be consistent. Why do you want to be consistent? Because you want to compare the two things. So it's nice that everything is in cents or dollars. I would go for cents because the numbers look better. So I'm going to divide 200 by 12. I'm going to just go ahead and use my calculator. And it is 16.67. Now I'm going to say this is better. Case two, scenario two is a better deal. And how do I know? Because assuming the grapefruits are identical, they're the same size, this costs more. You're paying more here than you're paying here. I'm going to give you like a minute or two to process it. Let's see what's coming up. Number six. This one is a good problem. Okay. Very practical. Everybody uses this. If you travel on a map, 1/3 of an inch. Okay. 1/3 of an inch is about this. Inch is about this. Maybe this much is 1/3 of an inch. If your map, if the line is 1/3 of an inch, it represents 5 miles in the real world. Between New York and Olusim, I don't know how to pronounce it. I'm going to call it City A. The distance between New York and City A is 18 inches. Okay. In your map, in reality, it's in miles, I'm sure. So how do we do that? So first, I'm going to pretend on my map, this is 18 inches. Okay. Let's write it down somewhere. In my map, this is an 18-inch line. Now, 1/3 of an inch, okay? 1/3 of an inch is going to be about this much, let's just say. Okay, three of them will make an inch. Okay, 1 inch, 1 inch, and I have 18 to go. So to find, I want to find out the answer. I want to know how many times 1/3 goes into 18. And how do I do that? I can do it this way. 18 divided by 1/3. Okay, don't multiply 18 by 1/3. That's not going to work. How many times 1/3 of an inch goes into this long 18-inch line? This is going to be, remember how we divide fractions? 18 times 3 over 1. Of course, we don't write 3 over 1, we just write 3. 18 times 3 is 54. Let me double check. 54. Let me double check. 30, that sounds about right. Now, I know 1/3 of an inch. You can take this 18-inch long strip and cut it up into 54 pieces. Each piece will be 1/3 of an inch. But again, 1/3 of an inch is equivalent to 5 miles. How do I know? Right here. 5 miles. So what's the distance between New York and City A? Let's say this is New York and this is City A. It's going to be 54 little pieces. There are 54 1/3 of an inch pieces in this long strip. Each piece is 5 miles. So I'm going to multiply that 54 by 5 to get the answer. I have to pause and reflect to make sure I did my calculation right. 50, that sounds about right. This many miles. Again, I'm going to pause just a little bit. just a little bit to make sure you copy it. You can do screenshot. You can take notes. Give me a minute. Okay, guys, let's look at problem number 7 if we don't have any questions on this. Problem number 7 is a rate problem. David reads 40 pages of a book in 50 minutes. How many pages should he be able to read in 80 minutes if he reads at a constant rate? So when you have a rate problem, when you're comparing two equal rates, you can always set up a proportion. You can say your first page relationship P1, which is 40 pages, per 50 minutes, that's your time one. Okay, must equal P2, the number of pages you're looking for, and how much time? 18 minutes. I'm going to call it T2. You can always set it up. It's called setting up a proportion. You can take your pages and then this time, then the pages you're looking for, and this time. You can set it up like I did. You can put T1 on top, T1 over P1, T2 over P2, your choice. So I'm going to just leave it like that because it's adequate. P1, one of the fractions is going to be the pair that you see. P1 is 40 pages. I'm going to replace this with 40. Time 1, how much time does it take for David to read 40 pages? 50 minutes. Okay, what are you looking for? How many pages would you read? So you're looking for P2. Okay, you can call it X, but I'm not going to worry about it. P2 is 80. Okay, now we're almost there. I'm going to take this, I'm going to simplify it just a little bit. I can do this. I can cancel the zeros. Okay, then I am going to multiply both sides by 80. And since it's being recorded and you can see the steps, I'm just going to multiply it right here. And if I apply the right-hand side by 80, I get this. If you divide 80 by 5 and then multiply it by 4, you're going to get, I'll just do it. 80 divided by 5 is 16. 16, which is 16 times 4 is 40, 64. This turns out to be 64. And kind of intuitively makes a little bit of sense. It's reasonable. I'll tell you why. Look, if David takes 50 minutes to read 40 pages, he takes 100 minutes to read 80 pages, and 80 minutes will be less than 80, more than 40. So it seems reasonable. I'll say my answer is 64 pages. That's my answer. So I have one more problem to do, then I'll take some questions. So I can pause it just a little bit. Actually, I might be able to squeeze in. It's giving me 10 minutes. We are fine. I'll give you 1 minute to process this and ask questions. So, guys, let's do this. Let's get out of this session and quickly come back. Okay. I'm not done. I have one more problem to do, and I don't want to be rushed by this little ticker that's telling me it'll kick me out. So, let's jump out of this room, use the same link to come back right away. We are not finished. I'll see you soon.